The third model is the relational model, and I'm sure many of you have actually heard of these because this is basically where you have your Microsoft Access, your SQL Server, your Microsoft SQL, your MySQL, Oracle, or some other database. And basically, if you know SQL, the programming language, you know that there's basically 8 relational operations. All the data is stored in tables, and as such, there's really only 4 commands in SQL, core commands. There's many others, but you basically can get away with 4. And they are select, I want to get the data, insert, put data in, update a particular record, and delete a particular record from a table. And what you do is within these databases, you will connect tables to other tables. And this is where you have these notions of pointers and keys. Now, these systems aren't necessarily as efficient as hierarchical or network systems just because of the way the architecture is built, but they are very, very flexible. They're easy to understand, and it's much easier to understand an Excel spreadsheet, which is basically a form of a table, and even a workbook, which has multiple spreadsheets. So that would be a database that has multiple tables in it, as opposed to a very core programming type of structure that links data together that might be used more in a scientific realm as opposed to a business realm. With these first used to handle end-user queries, it was the first time that we could actually have a programming language like SQL that allows end users to write their own queries. And this had an interesting drawback as well, because now end users could do a lot of work with the database directly. But the problem is that with that knowledge comes a little bit of responsibility. And if they write queries that are very long running, you could slow the entire system down. And so it becomes a little bit of a maintenance nightmare from an IT perspective to allow them to do it. Conversely, there's another problem where people say, well, I can't get the data out of the database that I need, so I'm going to make a copy of the data, and I'm going to work with that copy on my local machine. Now you have 2 copies of the data. Again, because it was easy to do, and it's easy to query the data, end users basically could make those judgment calls and run a copy of the data and thus create this new problem. So it does pose a challenge for IT management, but these are things that are very commonplace, and there are standards within companies that try and say what you can and can't have on your desktop or what you can and can't have within your own department. And sometimes it works and sometimes it doesn't. The object model is a little bit different because the object model, where relational models really excel at, is in storing structured data. And what I mean by that is that you store numbers and text and you have your strict columns. But imagine taking that Excel spreadsheet and in column or cell C5, you want to store an image. And in column D32, you want to store a video. And in A71, you want to store an audio. It's not conceptually clear as to how that works. And even Excel really just doesn't handle that. You can do paste of an image, but when you get to videos and you get to audios, it's a little bit different. But what object models do is they allow you to do that because it stores the data in this notion of an object. And so I can have any data type I want, whether it be text, numeric, alphanumeric, or a larger type of object such as an image, which would just be a sequence of bytes, and audio, same thing, and video. But it knows how to handle that, and it handles it effectively. The tenets of objects have become increasingly important in computing. So you'll see the notion of object-oriented programming, that Java is an object-oriented programming language. And there are databases that will work fairly well with those types of data sets that come in. In fact, if you deal with Facebook or Twitter API, which is the programmer interface to connect to them to pull data, what you'd find is that when it returns data back to you, it's returning it to you in an object. So therefore, using an object model or an object type database would make it easier to put the information in, and ultimately it's fairly simple to query. And there are similar constructs that these object databases have that will allow you to use a form of SQL to actually pull the data out. They do retain traditional relational database features, and because they do have end-user tools. They have a query language very similar to SQL. In fact, it's almost identical. It's easy to understand. Concurrency control, which basically means that 2 people cannot write to the same record at the same time. That would obviously be a problem. So it has this notion of locking, where you can lock a record for write so that you don't have 2 writes occurring at the same time. Recovery, being able to recover if you make a mistake, you can actually go back to the previous state of a record, and the ability to handle large amounts of data. That's ultimately where object models really excel at. So there are plenty of database products. Many of you may have heard of some of them. You've probably heard of MySQL, Oracle. I didn't put Access in there, but MySQL Server. You may not have heard of Postgres or Informix. These are relational databases. We also have the emergence of the big data databases, and you'll have things like Hadoop, which you can go online with, and it's an open source. And this is basically a way to handle large amounts of data. It's really not fair to think of Hadoop or big data as a regular database because it is fundamentally different. It is doing things at a file system level. You really have to think of it like a big drive, with like a C drive where it's storing different items on that drive, and it knows how to query or pull the different elements on those drives. You have relational analytical databases here, like Teradata, which is a very, very large database that does a high parallel processing, and NoSQL type of object databases, which are things like MongoDB. MongoDB is a very popular one that you can actually download and run on your computer as well.